I am Dr. Pushpal Ghosh, working as an assistant professor in Department of Chemistry, Dr. Odyssey Center University. Today we will deliver talk on a very interesting topic, an Odyssey of Indian science from ancient to Renaissance. As a nation, we are currently celebrating the 75th years of our glorious independence. In this auspicious occasion, it is necessary to revisit and reassess different historical aspects of our great nation so that we can go ahead strongly to our future. All over the world, there is now a trend to find the roots because the roots produce the plants. History as generally represented does not consist merely in the shifting of geographical boundaries of countries, in the military exploits of royalties and nations, or even in the undulation and migrations of lesser or greater waves of population. Rather, real history of mankind is constituted by the thoughts of the past, the leading conceptions of all remarkable forms of civilizations, the achievements of all genius, of virtue and of high faith. In brief, it is a record of the past experience of humanity and of the evolution of the human mind with its ideas and sentiments, its truths and toils, its virtues and guilt. India or Bharat is the only living and continuous civilization whose written record of history is of more than 5,000 years. The rich heritage of ancient and eternal Indian knowledge and thought is cleverly suppressed and hidden not only to the outer world but also to the majority of Indian itself. The pursuit of knowledge, Gyan, wisdom, Pragya and truth, Kshatriya, was always considered in Indian thought and philosophy as the highest human goal. The Indian knowledge system produced great scholars such as Charaka, Sushruta, Aryabhatta, Varahamihira, Bhaskaracharya, Brahmagupta, Chanakya, Chakrapani Datta, Madhava, Panini, Patanjali, Nagarjuna, Gautama, Pingala, Shankardev, Maitreyi, Gargi and Thiruvalluvar among numerous others who made seminal contributions to world knowledge in diverse fields such as mathematics, astronomy, metallurgy, medical science and surgery, civil engineering, architecture, shipbuilding and navigation, yoga, fine arts, chess and more. In this lecture, I will try to show how Indian science, especially chemical science, evolved since time immemorial, that is in the last 6,000 years ago, how it is declined since 14th century and then again resurrected on the onset of 19th century. I have taken utmost precaution to assume a psychological detachment against all prejudices that tend consciously or unconsciously to exalt national, religious or racial pride. But my sincere effort is to showcase the scientific temper which is carried by this blessed land since time immemorial. Though there are debates about time range, especially for the Vedic and Harappan civilizations or their connections, especially based on the recent analysis and excavations as recently found in Rakhi Gauri, I have considered the time range which is presently accepted and followed. First, I will explain how science, especially chemistry, had been used in pre-Harappan, Indus Valley and post-Harappan period, which is normally 4000 BC to 1500 BC. Then I will come to Vedic period, which is normally considered as 1500 BC to 600 BC. Ayurvedic period 600 BC to 800 AD, transitional period 800 AD to 1100 AD and Tantric period 700 AD to 1300 AD, and then I will explain decline of scientific spirit in India. So, let us first focus on the pre-Harappan period, which is normally considered as 2000 BC to 4000 BC. So, evidences of cultural settlement has been obtained from Baluchistan and neighboring parts of Sindh. Excavation indicated Bronze Age culture. Different colors were used in potteries excavated from these sites. For example, pottery excavated at Nal show red, blue and yellow paint, copper axes, chisels etc. are found, and modern analysis reveals that those instruments consist almost, for example, 93.05% copper, 2.14% lead, 4.80% nickel and trace amount of arsenic. Pottery and other objects indicated that they have used furnaces with reducing atmosphere which can heat up to 700 to 800 degrees Celsius, but no evidence of cast copper indicates that they were not able to prepare furnace which can melt copper at 1100 degrees Celsius like modern times. So, this is the jar found in Nausarao in which is range around 2700 to 1800 BC. Now, I will come to the Indus Valley civilizations, or recently it is called as Saraswati Sindhu civilization, which time range around 2500 BC to 1800 BC. This civilization was developed on the flood plains of Indus and its 5 tributaries. It was extended from Markan coast to Kathiawar, bounded on the west by the mountains of Baluchistan and Waziristan, on the north by Himalayan hills and on the east by Thar districts. This civilization is marked by populous cities, almost 40 in number, highly skilled industries, extensive commerce with river communications, a pictographic script and definite standards of weights and measures. So, excavation revealed the colored potteries, articles of faiences, beads, metallic objects etc. Faience, which is normally one type of pottery, indicates that they started coloring with suitable mineral matters. The tempering materials they have used with clay were mica, sand and lime. One archaeological chemist analyzed and confirmed that the colors are due to the iron compounds in the clay which develop a red shade in the oxygenating atmosphere of the kiln, while black or grey products are obtained when a reducing or smoking atmosphere which prevails in the course of burning. Bright red colors due to the ferric oxide like pottery. Harappan people were expert in preparing various types of bronzes. So, Indus Valley metallurgy practiced both casting and forging. You may know that in casting, metal had to be previously melted before being poured in the mold. So, this indicates that they were able to prepare high temperature furnace which can heat up to 1100 to 1200 degrees Celsius, which currently we are using. Also, they developed seals, dyings with different minerals etc. So, this table shows the different chemical composition found in potteries and other materials from the Harappan civilizations. So, this is the pottery you are looking from the this is the pottery kiln from Mohenjo-daro. This magnificent flower vase is obtained from the Indus Valley civilization. It is around Harappan in the southern Pakistan around 2400 BC to 2600 BC range. Now, I will discuss about the post Harappan period, which is considered as 1800 BC to 1500 BC. Due to decline of Indus Valley civilizations due to different reasons which I am not going here, refugees from these areas migrated towards east and towards south. So, the explorations at Shahitump, Chanudaro and Jhukar show the development of a distinct culture as a result of intermingling of the newcomers with earlier residents. Similarly, a large number of copper tools, sometimes in hordes of more than 400, 424 or more copper implements, 102 pieces of thin silver plates have been found notably at Gungeria near Balaghat in MP. And similarly, in Raipur, in Bijnor district, Fatehgarh, Bulandshahr, Ranchi, different kind of shells, barbed spears, swords are found. So, this indicate that the refugees are coming from their original settlement. The depositions suggest that a time of instability and insecurity as the panicky refugees were retreating from their place, and say they put it in certain places. Now, I will focus on the Vedic period, which is normally considered as 1500 BC to 600 BC. So, Rig Veda is regarded as a genuine document of the period from 15th to 12th century. In Rig Veda, we find mention of only gold, silver, copper and bronze. Some believe that iron was known during this time for the world, for the world Ayas in Rig Veda, but people differ. In Brahmanas and Upanishads, which is in later date, the word Ayas was differentiated between Lohitayas or red metal, which is called copper, and Krishnayas or black metal or iron. So, references related to the preparation and tanning of leather is also observed from Rig Veda. Shoma, a fermented juice from the stems of Shoma plant, had been highly extolled and invoked as the representation of divine power. Similarly, Madhu, Shura, that means evidence of brewing from barley grain, curds or fermented milk is noticed. In Atharva Veda and Yajur Veda, which is normally 10th to 11th century BC, 6 metals are mentioned. That means Ayas, gold, Hiranya, silver, Loha, copper, Sama, iron, Shisha, lead and Trapu, that means tin. In Atharva Veda, we got the hymns how to cure many diseases and prolongation of life. For example, for hair growth and old hair, one hymn mentioned the cure. So, we find the origin of alchemical notions gathered around gold, lead, Shoma juice and other medicinal plants as the age of Atharva Veda in India, which is around 10th to 11th century BC. Now, we will focus on the Ayurvedic period, which is normally considered as 800 AD to 600 BC. And most importantly, the constitution and properties of matter, atomic theory was developed at this time. This period constitute the most flourishing and fruitful age of ancient India relating to the accumulating and development of knowledge in chemical science. But as chemistry has to deal primarily with the composition and changes of matter, a concise preliminary summary of the salient features was developed during this time. Though these were purely speculative in character, with little or no experimental verification, being the result of only systematic and logical thoughts, yet they may be said to stand in good comparison with some of the most recent and advanced scientific ideas of our own time, and bear the stamp of high intellectual perfection and sublime intuition. In this regard, the Sankhya Patanjali view of the process of cosmic evolution, which was developed on 500 BC, is important. This theory was upheld by Patanjali in his yoga system. It represents the universe as based on the principles of conservation, transformation and dissipation of energy, as also on the conception of space, that means disha, and time, kala. According to Sankhya, the universe is evolved out of an unmanifested cosmic nature termed Prakriti. Prakriti is defined as an infinite, eternal, ubiquitous, indestructible, indifferentiated, indeterminate continuum. These are made of infinitesimal reals or gunas representing substantive entities. These entities are classified under 3 heads: Sattva, the essence or intelligent stuff; Rajas, the energy stuff; and the Tamas, inertia or matter stuff. These 3 gunas exist together in equilibrium or uniform diffusion in the infinite continuum, that is Prakriti. So Sankhya attributes the character of both quantum, that means parichinnata or continuity or extension, which is called pariman, to the energy stuff as well as to the matter stuff. It bears resemblances to our modern concept of energy and matter. Cosmic evolution in Sankhya is considered as a twofold process: creative as well as destructive, dissimulative as well as assimilative, catabolic as well as anabolic. The conception of space, desha and time, kala, and the idea of causality as elaborated in Sankhya are of surprisingly advanced character. Kapila, one of the originator of this philosophy, developed his ideas about the ultimate particles of matter. He gave ideas about 5 sub-T or infra-atomic particles named as tanmatras. He proposed Bhutadi, that is universe, is composed of 5 grosser elements: space or ether, that means akasha, air, vayu, fire, tejas, water, up, and earth, khiti. According to Sankhya, atoms, that means onus, of these grosser elements are composite units made up of infra-atomic particles. That means he called tanmatras. The atomic theory of Sankhya bears a great resemblance to the Greek theory of elements introduced by Empedocles, which is around 490 to 430 BC. Similarly, Chandogya Upanishad had described this cosmic evolution in an entire different way. This theory has some resemblance to the modern theory of evolution based on the idea of expanding universe. Now, Boisheshika system of Konadu is also very important. This theory focuses on the study of the properties of matter and nature of atoms and molecules. This theory has many points in common with that of the Greek philosopher Democritus, which ranges around 470 to 360 BC. And almost identical views are expressed in the Naya system of Hindu philosophy. The concept of onus, that means atoms, coming from Naya Boisheshika system is comparable to the tanmatras of Sankhya philosophy. Konada makes the remarkable statement that they are only the different forms of one and the same essential entity, Tejas. He also attributed certain characteristics properties like mass, gravity, fluidity, velocity, elasticity, as well as some characteristic potentials of sense stimulus like color, taste, smell or touch. According to him, atoms are eternal and indestructible, though they cannot exist in free or uncombined state. He also gave some idea of combination of atoms. Very interestingly, atomic theory of the Jainas, which is around 40 AD, was also surprisingly advanced. Their view bear a resemblance to the dualistic hypothesis of chemical combination propounded by the great Swedish chemist Berzelius nearly 1800 years. Now, I will describe chemistry in Kautilya, that means Chanakya's time. After advent of Ayurveda from the time of Atharvaveda, different philosophies of cosmic evolution came. The earliest and most authentic knowledge of chemistry, metallurgy and medicine of those days are found in Arthashastra, which in English is called Treatise on Polity by Kautilya or famous Chanakya. He gave an account of ores, minerals and metals with their extraction and working, as well as alloys. For example, he also explained the qualifications of officer who will supervise the mining or being the superintendent of mint or coins. What qualifications he should have or she should have? The superintendent of the mint shall carry on the manufacture of silver coins made up of 4 parts of silver and 1 part of any of the metals, that means iron, tiksna, tin, trapu or lead, sisa. He also explained how to check quality of metals, different types of salts, acids in liquid forms like curds, the extraction of various oils from seeds, knowledge of fermentation. It is interesting to note that Kautilya writes that all varieties of liquor other than that used for king are taxable with 5% as toll. Chemistry in the Charaka and Sushruta also is very important. Now, a time came when Hindu system of medicine was methodologized and arranged more or less on a rational basis with scientific terminology. The 2 earliest and most renowned treatises are on the name of 2 sages, Charaka Samhita, which is describes medicines, and Sushruta Samhita, medicines and mainly surgery. Charaka was more ancient than Sushruta and Sushruta was more systematic. Charaka himself records that he simply based his works on that of Ognivesha, who is disciple of Atreya, who according to Buddhist Jataka, which he also completely recast and remodeled. At the time of Charaka, there existed at least 6 standard works by Jatukarna, Porasara, Harita, Kharapani respectively. There are chapters in the Charaka Samhita which suggest that it seems to record the deliberations of a congress of medical experts that will discourse on the tests like present day conference. He mentioned 6 metals: gold, silver, copper, lead, tin and iron, and other calces as drugs. He mentioned 5 kinds of salts, different minerals like sulphate of copper, iron and sulfur have been prescribed in combination with vegetable drugs for uses as an external application in many skin diseases. He explained preparation of alkali. For example, he is writing, a young Butea frondose is to be cut to pieces, dried and finally reduced to ashes. The ash is lixiviated with 4 or 6 times weight of water and strained 21 times through linen. This obviously gives rise to a solution of potash carbonate. According to Charaka, medicines are classified under 2 main heads. One increases the strength and vitality of people already healthy, that in vital elixir. The other cure diseases. Sushruta made alkali of 3 different strengths like present day laboratory in solution, namely weak, moderate and strong. He also showed that Sushruta also showed how to neutralize alkali by acids. Sushruta has dealt mostly with vegetable drugs. However, in one sloka he used 6 metals: tin, lead, copper, silver, iron and gold. He also used minerals and chemicals like sulphate of copper, sulphate of iron, alamath, red ore, etc. He developed roasting of iron and compounds of arsenic. Though use of mercury is mentioned in 1 or 2 slokas, but his use was not clear at that time and somewhat vague. But Sushruta's actual talent was in surgery. Now, Sushruta's instrument for surgery even matches with today's equipment used for surgery at any OT, operation theatre. The Bauer manuscript, which is 4th century AD, discovered by a British lieutenant A. Bauer in 1890 in a Buddhist monuments in Chinese Turkestan, depicted a revised version of Charaka and Sushruta. Another genius was Bhagavata. His time was 800 to 850 AD. His treatise may be represented as an epitome of the Charaka and Sushruta with some gleanings from the works of Bela and Harita. Bhagavata introduces certain modifications and additions in the surgery described by Sushruta. He also used vegetable drugs along with metals and minerals, but in one occasion he used mercury. He is writing, take equal parts of mercury and lead and make them up into a collyrium with their equal weight of stibbium and camphor.